And then we can immediately see that 8 is the highest number of times, and this occurs at a value of 2. So mode is 2. So we have to remember we are finding the mean, mode, median of the variable, not of the frequency. So that confusion should be removed. Now for the median, we go to the central value. And since these are 15 observations, we'll find that the central value is this 2. So 2 is the median. If there is no central value, for example, even number of terms, then you take the middle value of those 2 terms which are in the center. So these formulae you can read in the book. There's nothing big in this, but since we'll immediately try to understand how the software can be used, that'll be a simple matter. But the concept should be clear. Concept-wise, these are the concepts of mean, mode, and median. And then mean is simply the sum of observations. This sign represents sum. These symbols also you should understand. Sigma, this is a Greek letter pronounced as sigma, S-I-G-M-A, sigma. This is capital sigma. You will also come across small sigma. For example, generally the population standard deviation is represented by sigma. So that is also sigma, but that's a small. Like in English alphabet, you have capital A and small a. Similarly, in Greek alphabet, you have capital letters and small letters. So both are pronounced as sigma. These are sigma. So sigma represents sum. Generally, when we want to represent sum, so we say x bar is equal to sum of the product of frequencies and x divided by sum of the frequencies. Sum of the frequencies gives the total n. Total n is equal to sum of the frequency. So sum of the frequency is equal to total n, number of observations. And sigma x here is 31. You can add these values. Therefore, x bar becomes 3 multiplied by 1 because frequency is 3. Frequency with which 1 is occurring is 3. 3 multiplied by 1 plus 8 multiplied by 2 plus 4 multiplied by 3. This will also come to be 31 and divided by the total number of observations. This is total number of observations will be here. The sigma frequency will be, this will be 15, not 1, 2, 3. Okay. So the mean is 2.1. Now, if that happens, if mean, mode, and median coincide, here they are generally coinciding, then we say the distribution is symmetrical. If they do not coincide, then the distribution is not symmetrical. So we'll see this again as we proceed further when we talk about the various aspects of distribution. Let me remove this, otherwise there will be some problem again. Chalo x-axis bhi hat gayi, doesn't matter. I'll draw them again. Now let us go to the measures of dispersion. And we had talked about the range, the IQR, MD. We'll see how we calculate IQR, mean deviation, etc. And we had done this analysis here. And if there's any question in this, because we have done it, if you want to ask any question, please do ask. 2 important points that were made were that covariance of the standard scores, standardized data or standard scores is also the correlation coefficient. And Pearson product moment correlation coefficient can be computed by changing them into standardized scores. So basically covariance is nothing but correlation is nothing but standardized covariance. But that also you have to remember. But now generally, how do you, when there's a large number of variables, then how should we summarize the final results? So I'm just telling you this because, this information is important, and this can be very useful later on. So you represent it you will come across a term called the covariance matrix. Covariance matrix is a matrix that represents what are the variances and covariances of the variables. So there are two variables, x1 and x2. x1 and x2. So what is the covariance of x1 and x2? That will be the variance. So variance of a variable is equal to its covariance with itself. And therefore we write here variance here is 1, variance here is 4, and x1, x2, this is x1, x2, and x1, x2 variance, covariance is 4, and variance here is 1. So this is how, this can be done. And what is variance of, what is covariance? Covariance is 2 actually, not 1. Covariance is, covariance of x1 and x2 is 1. So that's how these matrices can be made. But that is for when you have a large number of variables, and generally when you will do research, you will come across the variance covariance matrix. It is simply called covariance matrix, and the variance is consumed under covariance of a variable with itself. Now there's a concept called coefficient of variation. This is an important concept because it gives a standardized measure of dispersion. How do we standardize the measure of dispersion? By dividing standard deviation by its mean. So if you have a set of scores, and if you have computed standard deviation divided by the mean of the distribution, you will get coefficient of variation. For population, the coefficient of variation is written as sigma by mu. Mu, this is called mu. Mu is also a Greek letter, and capital is M. Capital is generally written as capital is M. So, but you don't worry about that. So Greek letter is mu into 100. So for population, and formula is the same, standard deviation divided by mean into 100. That is the percent of coefficient variation in the data. So it's a measure of volatility. Coefficient of variation is a measure of volatility or risk. For example, in financial investments, how much will the investment be affected by any change, with passage of time, etc.? Will the instrument show a larger variance? I give you an example, simple example. Suppose there are two groups, and you collect information on aggressive behavior. If you collect information on aggressive behavior of these two groups, then you find that the coefficient of variation of group 1 is higher than the coefficient of variation of group 2. That would mean that group 1 is more volatile. We don't know when they will become aggressive, when they will be calm. But group 2 is less aggressive. So volatility means that there's a sudden change in behavior, and there's a risk involved in that. So you may not like to interact with group 1 because group 1 is very volatile, may become aggressive. Group 2 is calm, simple, etc., etc. So CV indicates the kind of uncertainty, the change in behavior, sudden changes in behavior, large changes in behavior, and dispersion in their scores of aggressiveness, for example, will be more will be high. But for a group which is calm, this will be low. So this can be example from the psychological domain, sociological domain, maybe interactions between groups. So lower value of CV is better. What does it indicate? If you plotted the observations of the two groups, then in one group, if we plotted the scores, observed values of X, that is aggression, in one group it may show results like this, in another group it may show results like that. So here you can see that the value of CV here is greater because standard deviation of this distribution 1 is higher than the standard deviation of the group 2, or dispersion is higher, and standard deviation is a measure of dispersion of the scores. Therefore, group 1 will show a distribution of the flatter kind and larger value of CV because sigma is higher. Group 2 will show a smaller value of CV, and therefore it is more stable group. So stability or volatility, that can be understood. So CV is to be understood in that way. Now, so let us, I'm sorry, I have to remove all this, otherwise ये save हो गया तो मेरा फिर problem आएगा. So now, which statistic is more economical, mean or median? This is an important question. Why should you use mean in most of the analysis? First reason is that when you have to do some higher level of analysis, then mean is more useful. In fact, the whole statistical analysis is about variation in data, variance. And standard deviation can be defined only for the data which are metric and where mean can be computed. But if we compute the median, then we generally compute IQR, interquartile range or range, etc. And therefore, that is not a very useful statistic for higher level analysis. One reason is that. Another reason is that by economical or efficiency, we mean sample size. If we can get the same results by using a smaller sample, then it is economical because we'll have to spend less money, less time, and we get the results which are as powerful as we would have obtained with a larger sample if we use mean. That is why mean should be used. So there are other reasons, because you should read a textbook where they give reasons, the characteristics of various descriptive statistics. I have not gone into that because that's only a descriptive material. Statistics should be efficient, it should be consistent, it should be robust. These are some of the characteristics of the descriptive statistics, which must be. So it should be as unbiased. Mean is the best. Mean is an unbiased estimate of the population. Mean of a sample is the unbiased estimate of population. It is also consistent, etc., etc. So I'll not go into those definitions, but you please read the textbook. I have named 2 textbooks for you. I have not named many textbooks. Those 2 textbooks are sufficient to understand these concepts. So standard error of mean, there is a term called standard error. I'll define this term when I go to the inferential statistics. How do we draw inferences from our results? There I'll define standard error. Standard error is a very useful concept. Standard error of mean is defined as sigma x bar square. This is how it is written. So when we say standard error, we write a suffix x bar to sigma. But if we don't write the suffix x bar, we are talking about standard deviation. So that is the only difference. So sigma is the standard deviation. Sigma is the standard deviation or variance here because I am taking square. And sigma x bar square is the standard error. This is the only difference. Standard error of mean is defined as sigma square. Actually, square of the standard error of mean is defined as sigma square by n. So standard error will be sigma by root n. For median, it is defined as 1.57 times sigma square by n. So standard error of mean is 1.57 times the standard error of median is 1.57 times the standard error of mean. If we take their ratios, we can find the relative efficiency of mean to median. So the ratios will be sigma square by n divided by 1.57 multiplied by sigma square by n. This will come out to be 0.64. So 1 upon 1.57 will give you a value 0.64. What does it mean? It means that with 64 subjects, we can get those results. We can get results about a sample, etc. if we use mean, as we will get when we use median with 100 subjects. So now you can see that 64 subjects and 100 subjects, there is a large difference. About 2/3 of the subjects will be sufficient if we are using mean. We'll require more subjects than that if we want to use median. What about the absolute value of CV? The absolute, I can plot this absolute value of CV on a line, straight line, and if the CV is less than 0.2, then it represents a stable behavior. So smaller the CV, better it is. I have removed that curve. Smaller the CV, better it is. Larger the CV, more volatile. Therefore, if the CV is found to be less than 0.2, the behavior is stable. So aggression, for example, there will be no sudden aggression of that group. And if CV is close to 1 and higher than that, this is unstable behavior. So now you can use this to, let's say you want to give a psychotherapy to some people who are aggressive, who show aggression, and you want to give a therapy and you want to change their behavior. That would mean that they are showing unstable behavior. So you give some kind of training so that the dispersion can be reduced.